Okay, question 13. It is a real exam level question, and I'd be so proud of you if you did this on your own. Let's have a look. Well, I think our first step is going to be to expand this. We can take up lots of space. 1, 6, 15, 20, 15, 6, 1. I'm going to need so much more space than this. Not necessarily with the 1, but everything else. Okay. Now, we've got MA. Oh, I'm going to go with a thinner pen. MA to the 6. MA to the 5. MA to the 4. MA to the 3. MA to the 2. MA to the 1. And the rest go. And the rest is n over a squared. So, n over a squared to the 1. N over a squared to the 2. N over a squared to the 3. N over a squared to the 4. N over a squared to the 5. N over a squared to the 6. Okay, now we're trying to find, in particular, the ones where we're going to have an a to the 3 and an a to the minus 3. We're definitely not going to have it from the first one. And we're not going to have it, like there's no way it can happen from this one, because we're going to get an a to the 10 on the bottom and not this one. We could get it from the others, like you probably can see already whether we're going to get it or not, but I'm going to do these other ones step by step. But those first ones are the ones I could eliminate straight away. So this one's 6 times m to the 5 times a to the 5 times n on a squared. This a to the 5 and a squared, it's going to end up as a3. So this is definitely one that we need to consider. This next one, we've got 15 times m to the 4, a to the 4 times n squared over a to the 4. Those a to the 4s are literally just going to cancel out. This is not one we need to worry about. Okay, 20 times m to the 3, a to the 3 times n to the 3 over a to the 6. A to the 3, a to the 6, we get a to the 3 on the bottom, which is a to the minus 3. This is one we care about. And I'm just doing this one just to double check. So we've got 15 m squared, a squared, n to the 4, a to the 8, 2 and 4, 2 and 8, 6. No, that's not one we need to care about. So these two are the ones we need to care about. So I'm just going to expand them properly. So we've got 6m to the 5 n, a to the 3. I've just rejigged it so the a to the 3 is last. And we've got 20 m to the 3, n to the 3, and that's a to the minus 3 because it's on the bottom. So the coefficients we're going to be caring about, coefficient doesn't include the a3, it's the coefficient, the number in front, is that one and that one. And they're saying that these coefficients are equal. So we know 6m to the 5n is equal to 20 m to the 3, n to the 3. And we know m and n are not 0. Okay, I'm going to just get all my m's on one side and my n's on the other. So I'm going to do that by dividing by n. And I'm also going to divide by m to the 3. So on the left hand side, my n's cancel out. On the right hand side, my m to the 3's cancel out. I've also got, I'll do this in a different colour, my m to the 5 and m to the 3, that becomes 2. And my n to the 3 and my n, that becomes 2. So I've got 6m squared equals 20n squared. When they ask us to prove that, no, I'll choose a different colour. What's one we haven't used? This. When they ask us to prove this, that's the same as us proving m squared over n squared equals 10 over 3. So I'm going to get m squared over n squared by dividing both sides by n squared. So now I have 6m squared over n squared equals 20. Divide both sides by 6, I get m squared over n squared equals 20 over 6. What is 20 over 6? That simplifies to divide them both by 2, 3 on the bottom, 10 on the top. Proven. Done. Woo! Yeah!